Hi everyone, today we're going to talk about naive Bayes model. But first, let's discuss about a short description of algorithm. In computer science, an algorithm is a set of instructions for solving some problem. Though computer-run algorithms constantly, humans can also solve problems with algorithms. For example, how would you go about counting these men? Well, you probably count at each person one at a time and count up from 0 to 5. And that's an algorithm. Now to business, what is naive Bayes model? In machine learning we are often interested in selecting the best hypothesis, H, given data, D. In a classification problem, our hypothesis, H, may be the class to assign for a new data instance, D. One of the easiest ways of selecting the most probable hypothesis given the data that we have that we can use as our prior knowledge about the problem. Bayes' theorem provides a way that we can calculate the probability of a hypothesis given our prior knowledge. Bayes' theorem is stated as where the underlined above is the probability of hypothesis H given the data D. This is called the posterior probability. Another is the probability of data D given that the hypothesis H was true. The other one is the probability of hypothesis H being true regardless of the data. This is called the prior probability of H. And lastly is the probability of the data regardless of the hypothesis. After calculating the posterior probability for a number of different hypotheses, you can select the hypothesis with the highest probability. This is the maximum probable hypothesis and may formally be called the maximum a posteriori hypothesis. This can be written as the probability of the data is a normalizing term which allows us to calculate the probability. We can drop it when we are interested in the most probable hypothesis as it is constant and only used to normalize. Naive Bayes is a classification algorithm for binary and multi-class classification problems. The technique is easiest to understand when described using binary or categorical input values. It is called naive Bayes or idiot Bayes because the calculation of the probabilities for each hypothesis are simplified to make their calculation tractable. The representation for naive Bayes is probabilities. A list of probabilities are stored to file for a learned naive Bayes model. This includes class probabilities, the probabilities of each class in the training dataset. Conditional probabilities, the conditional probabilities of each input value given each class value. Naive Bayes can be extended to real-valued attributes, most commonly by assuming a Gaussian distribution. This extension of naive Bayes is called Gaussian naive Bayes. Other functions can be used to estimate the distribution of the data, but the Gaussian, or normal distribution, is the easiest to work with because you only need to estimate the mean and the standard deviation from your training data. When we discussed naive Bayes, we calculated the probabilities for input values for each class. With real-valued inputs, we can calculate the mean and standard deviation of input values, for example x for each class, to summarize the distribution. This means that in addition to the probabilities for each class, we must also store the mean and standard deviations for each input variable for each class. Let us learn a Gaussian naive Bayes model from data. This is as simple as calculating the mean and standard deviation values of each input variable, which is the x for each class value. This is the formula of calculating the mean, where n is the number of instances and x are the values for an input variable in your training data. We can calculate the standard deviation using this following equation. This is the square root of the average square difference of each value of x from the mean value of x, where n is the number of instances, sqrt is the square root function, sum is the sum function, xi is a specific value of the x variable for the ith instance, and mean, x, is described before, and the underlined above is the square. Let's make a prediction with Gaussian naive Bayes model, whether we'll go out in a car based on the weather. Where PDF, x, is the Gaussian PDF, sqrt is the square root. Mean and SD are the mean and standard deviation calculated before. Pi is the numerical constant, exponential is the numerical constant e, or Euler's number raised to power, and x is the input value for the input variable. We can then plug in the probabilities into the equation to make predictions with real-valued inputs. For example, adapting one of the above calculations with numerical values for weather and car. The naive Bayes classifier model outperforms several other higher-level classifiers in many cases. There are many other variations of naive Bayes like multinomial naive Bayes, binomial naive Bayes, Bernoulli naive Bayes. All perform differently with the same dataset. All of these should be used and tested for determining which one is best suited for the text classification purpose. Thank you for listening.